Some of the coolest aircraft ever built never made it into service. Today we're looking at 10 secret prototypes that could have changed aviation forever. These weren't your typical planes. We've got flying rams, vertical takeoff fighters, and aircraft that look like flying saucers. Each one had amazing technology that was way ahead of its time. Some failed because of politics, others because the tech wasn't ready yet. But all of them show us how different our skies could have looked. Let's count down the 10 most incredible secret aircraft that almost made it. Imagine an aircraft so radical that its primary weapon wasn't bullets or bombs, but itself. In the final years of World War II, when German jets threatened Allied air supremacy, American engineers conceived something that sounded like pure madness: a flying battering ram. The Northrop XP-79B flying ram emerged from the brilliant mind of Jack Northrop in 1945. This wasn't just another fighter, it was a revolutionary flying wing designed to literally ram enemy aircraft out of the sky. The pilot lay prone on his belly, protected by reinforced magnesium armor, while twin rocket engines provided incredible speed and maneuverability. The entire leading edge was designed as a cutting weapon, capable of slicing through bomber formations like an aerial sword. What made this prototype truly revolutionary was its construction. The entire airframe was built from reinforced magnesium, making it incredibly light yet strong enough to survive ramming attacks. Test pilots reported unprecedented maneuverability. This aircraft could turn and roll faster than anything else in the sky. But the XP-79B's first and only flight on September 12, 1945, ended in disaster when test pilot Harry Crosby lost control during a routine maneuver. The war was ending, jet technology was rapidly advancing, and the concept of ramming attacks seemed increasingly obsolete. Had it succeeded, aerial combat might have evolved into something resembling medieval jousting tournaments in the sky. What if we told you that in 1954, engineers built a fighter jet that could take off like a rocket and land on its tail like something from a science fiction movie? Deep in Convair's secret facilities, they were solving one of aviation's greatest challenges: how to launch powerful fighters from anywhere, without runways. The XFY-1 POGO was born from pure necessity. The US Navy needed fighters that could operate from small ships, remote locations, or even city rooftops during the Cold War. This vertical takeoff interceptor sat on its tail like a towering monument, its massive contra-rotating propellers providing enough thrust to lift the entire aircraft straight up into the sky. Once airborne, the pilot would literally tip the aircraft forward to fly normally, then perform the reverse maneuver to land vertically. The engineering was breathtaking. The cockpit could rotate, allowing the pilot to see properly during vertical operations. The landing gear was designed like a tripod, keeping the aircraft stable while sitting on its tail. Test flights proved the concept worked. The POGO could indeed take off vertically, transition to horizontal flight, and land on its tail with precision. However, the project revealed a fatal flaw. Transitioning between vertical and horizontal flight required skills that seemed almost superhuman. Only the most exceptional test pilots could master the complex procedures. The program was cancelled when jet technology offered simpler solutions. But imagine if every city had been defended by these rocket-like sentinels. In the depths of the Cold War, British engineers embarked on a mission that seemed impossible, building an aircraft that could fly at 3 times the speed of sound for hours without melting. What they created was unlike anything that had ever taken to the skies, a plane made entirely of stainless steel that looked like it had flown straight out of the distant future. The Bristol Type 188, developed in secret during the late 1950s, was Britain's answer to the thermal barrier. When aircraft approach Mach 3, the friction with air creates temperatures hot enough to melt conventional aluminum. So Bristol's engineers did something unprecedented. They built the entire aircraft from stainless steel. The result was a gleaming, mirror-like machine that could theoretically handle the extreme heat of sustained supersonic flight. The engineering challenges were staggering. Every component, from the smallest rivet to the massive fuel tanks, had to be crafted from steel. The aircraft carried enormous fuel loads because steel construction made it incredibly heavy. Its twin afterburning turbojets pushed it beyond Mach 2, proving the concept could work. But the Type 188 arrived too late. Intercontinental ballistic missiles were making high-speed interceptors obsolete, and the massive cost of steel construction seemed unjustifiable. Only 2 were ever built, both now museum pieces. Had the Cold War taken a different turn, fleets of these steel birds might have patrolled our skies, invulnerable to the heat that destroyed other aircraft. Picture a needle with wings, an aircraft so sleek and sharp that it looked more like a piece of modern art than a flying machine. Hidden in the California desert during the early 1950s, Douglas Aircraft was crafting something that would push the boundaries of what we thought possible in aviation design. The X-3 Stiletto was born from our obsession with speed. Engineers knew that to break through the thermal and sound barriers consistently, we needed an entirely new approach to aircraft design. The Stiletto was their answer, an incredibly long, thin fuselage with tiny, razor-sharp wings. Everything about it was designed to slice through the air with minimal resistance. Its proportions were so extreme that it barely looked capable of flight. What made the X-3 revolutionary wasn't just its shape, but its construction. The entire airframe was built from titanium and stainless steel, materials that were cutting edge for the 1950s. The landing gear was so small that the aircraft sat incredibly low to the ground, giving it an almost predatory appearance. The cockpit was positioned far forward, giving the pilot an unobstructed view of the sky ahead. Unfortunately, the Stiletto's engines were underpowered for its ambitious design. It never achieved its intended speeds, struggling to break the sound barrier despite its advanced construction. The project taught engineers valuable lessons about supersonic flight, but the X-3 itself remained a beautiful failure, a glimpse of what could have been if engine technology had matched its revolutionary airframe. Imagine opening a hangar door to reveal something that looks like it was built by aliens. A massive aircraft with no fuselage, no tail, just one enormous wing stretching 172 feet across. In the 1940s, while the world focused on conventional bombers, Northrop was secretly developing something that would make the B-29 look primitive by comparison. The XB-35 flying wing wasn't just unconventional, it was revolutionary. Jack Northrop believed that the most efficient aircraft was simply a wing, with everything else being unnecessary weight and drag. The result was a bomber that could carry the same payload as conventional aircraft while using 25% less fuel and flying 25% farther. Its smooth, curved surfaces made it incredibly difficult to detect on radar, decades before stealth technology became mainstream. The engineering was breathtaking. The entire crew, bombs, fuel, and equipment were housed within the wing itself. 8 pusher propellers provided propulsion, while the aircraft's natural stability made it incredibly smooth to fly. Test pilots reported that it felt like riding on a cloud. Virtually no vibration, no noise, just effortless flight. But the flying wing suffered from a fatal flaw. It was too advanced for 1940s technology. The complex flight control systems required constant pilot attention, and the propeller-driven design couldn't match the performance of emerging jet aircraft. The program was cancelled in 1949, but decades later, Northrop's stealth bombers would finally vindicate Jack Northrop's revolutionary vision. The future had simply arrived too early. What if we told you that in 1947, engineers built a passenger aircraft so massive it could carry 400 people across continents, decades before the Boeing 747 was even imagined? Deep in Convair's facilities, they were secretly constructing the largest aircraft ever built, a double-decker giant that would have revolutionized air travel forever. The XC-99 was born from wartime necessity, designed to transport entire military units across the Pacific. But its implications for civilian aviation were staggering. This wasn't just a cargo plane, it was a flying city. The upper deck could house passengers in unprecedented comfort, while the lower deck carried vehicles, supplies, or additional cargo. 6 massive radial engines provided enough power to lift this 320,000-pound giant into the sky. The interior was revolutionary for its time. Wide aisles, large windows, and spacious seating made it more comfortable than most airliners today. The cargo bay could hold tanks, trucks, or enough supplies to support an entire military base. Loading was accomplished through massive clamshell doors that opened the entire rear of the aircraft. Only one XC-99 was ever completed, and it flew successfully for over a decade. But the economics proved challenging. It was simply too large and expensive to operate profitably with 1940s technology. Had jet engines and modern materials been available, fleets of these giants might have made air travel accessible to millions of people decades earlier than it actually became. Picture an aircraft that flies backwards, or at least looks like it should. In the early 1940s, while conventional fighters ruled the skies, Curtiss-Wright's engineers were secretly developing something that challenged every assumption about aircraft design. What they created looked like it had been built in reverse, yet it promised to be the most maneuverable fighter ever conceived. The XP-55 Ascender was born from desperation. American fighters were being outmaneuvered by German and Japanese aircraft, and conventional designs seemed to have reached their limits. The Ascender's solution was radical. Put the engine in back, the propeller behind the pilot, and the tail in front. This pusher configuration eliminated the torque and prop wash problems that limited other fighters' maneuverability. The result was extraordinary. Test pilots reported that the Ascender could outturn any fighter in the sky. Its unusual weight distribution made it incredibly responsive to pilot inputs, while the rear-mounted engine provided excellent forward visibility. The aircraft could perform maneuvers that seemed impossible, tight turns, rapid climbs, and precision aerobatics that left conventional fighters behind. But the Ascender's revolutionary design came with hidden dangers. The rear-mounted propeller made bailouts extremely hazardous, and the unusual flight characteristics required extensive pilot retraining. More critically, jet aircraft were beginning to make propeller-driven fighters obsolete. Only 3 prototypes were built before the program ended, but they proved that sometimes the most radical solutions can also be the most effective. In the tense early days of the Cold War, Martin Aircraft was developing something that looked like it had arrived from the year 2000. Hidden away in their Baltimore facilities, engineers were crafting an attack bomber so advanced, so unlike anything else in the sky, that it would have redefined close air support forever. The XB-51 was unlike any aircraft ever built. 3 jet engines provided unprecedented power. 2 mounted in streamlined pods beneath the forward fuselage, and a third buried in the rear fuselage. The wings swept forward, then backward, creating an aerodynamic shape that seemed to defy conventional wisdom. The landing gear was revolutionary, a bicycle configuration with outriggers, allowing the aircraft to sit level on the ground while maintaining its sleek profile. What made the XB-51 truly extraordinary was its performance. This wasn't just fast, it was agile like a fighter while carrying the payload of a bomber. Test pilots reported that it could perform barrel rolls, loops, and precision maneuvers while fully loaded with weapons. Its three-engine configuration provided incredible acceleration and climb rates that left conventional bombers far behind. The flight tests proved the concept brilliantly. The XB-51 consistently outperformed its competitors, demonstrating capabilities that wouldn't be seen again until decades later. But politics intervened. The Air Force chose the more conventional B-57 Canberra, ending development of what might have been the most advanced attack aircraft of its generation. The future of tactical aviation had been in our grasp, only to slip away. Imagine walking into a hangar and seeing something that looks like a giant mechanical flying saucer, complete with propellers. In the early 1940s, while the world focused on conventional aircraft, Vought's engineers were secretly developing something so radical it would have rendered every other fighter obsolete overnight. The XF-5U flying Pancake was the brainchild of Charles Zimmerman, who believed that the ideal aircraft shape was a perfect circle. The result was unlike anything that had ever flown, a disc-shaped fighter with twin propellers that could take off vertically, hover like a helicopter, then accelerate to fighter speeds. Wind tunnel tests showed it could fly as slowly as 20 miles per hour or as fast as 460 miles per hour. Capabilities no conventional aircraft could match. The engineering was breathtaking. The circular wing generated lift at any speed, from hovering to high-speed flight. The twin propellers could be adjusted independently, allowing unprecedented control. The aircraft could literally stop in mid-air, turn around in its own length, then accelerate away faster than pursuing fighters could follow. Only one prototype was completed before the program was cancelled in 1947. The military was shifting focus to jets, and the Flying Pancake's complex mechanical systems seemed unnecessarily complicated. But those who witnessed its test flights never forgot what they saw, an aircraft that flew like something from another world. Had it entered service, aerial combat would have been transformed into something unrecognizable, with disc-shaped fighters dancing through the sky like mechanical UFOs. Picture the most luxurious airliner ever conceived. A palace in the sky capable of landing on any body of water in the world. In the late 1940s, while airlines focused on land-based aircraft, Saunders-Roe was secretly developing something that would have transformed air travel into the ultimate luxury experience while connecting every corner of our water-covered planet. The Princess was simply staggering, the largest aircraft ever built at the time, powered by 10 engines and capable of carrying 220 passengers in unprecedented comfort. But this wasn't just about size. The Princess represented a completely different vision of aviation's future. Instead of being tied to airports, it could land in harbors, lakes, or coastal waters worldwide. Passengers would board from floating docks, while the aircraft's hull allowed for spacious interiors impossible in conventional airliners. The engineering was revolutionary. The double-deck design provided enormous internal volume, while the hull construction made it incredibly strong and stable on water. The 10-engine configuration, 6 tractors and 4 pushers, provided redundancy and power that ensured safe operations even over vast oceanic distances. Test flights proved it could deliver airline performance while accessing destinations no land-based aircraft could reach. Only 3 were built before the program ended in 1954. Jet aircraft offered superior economics, and the flying boat era was ending. But the Princess represented the road not taken, a world where luxury air travel could have reached every waterfront city on Earth, turning our oceans into highways for elegant flying ships. So there you have it, 10 amazing aircraft that never made it. From flying pancakes to steel jets, each one shows how creative engineers got when trying to solve aviation problems. Some were too advanced, others too expensive, and a few were just plain unlucky with timing. But their ideas live on in today's aircraft. Modern stealth bombers and tilt-rotor planes use concepts from these old prototypes. Aviation is full of crazy ideas that almost worked. If you enjoyed this video, hit subscribe for more stories about incredible aircraft that almost changed everything.